All right, guys. Last week, I told you the stories behind Ursa Major and Ursa Minor, and I didn't get quite through talking about the two constellations, Ursa Major and Ursa Minor. So I just want to show you the stars that make up those two constellations. And then at the end of today's lecture, I'm doing a little review of what we've covered so far with global coordinate systems and geographic and local coordinate systems. So make sure you watch that. That'll be a good review for your quiz coming up on Thursday. And then it's always good to review for your test as well, whenever we have it. So let me just show you Ursa Minor and Ursa Major and talk about the stars that you need to know for them. So this is where we left off. I showed you these. So in this picture here, in this image, so this is a computer generated image of all the stars that make up these constellations. So in this image, you should be able to see the Big Dipper and the Little Dipper. And those are the asterisms. Last week we said an asterism is just how you find a constellation, is what you look for. So you look for the Big Dipper or Little Dipper to find Ursa Major and Ursa Minor. So Ursa Major is always the easier constellation to find. Ursa Minor is a little tougher because the stars aren't as bright. All the stars in Ursa Major, there are 1, 2, 3, 4, 5, 6, 7 to 8 stars in them. 7 stars really, we'll say that. If you count Mizar Alcor, we'd say 8, but 7 stars in Ursa Major, they're all really bright. In Ursa Minor, you have 3 stars that are bright and the other ones are not very bright. So in Ursa Minor, the 3 stars that are bright have names, proper names, and the other ones are just they're numbered by letter. Sorry, I said that wrong. They are lettered. Use Greek letters to name them, and that's in a type of system we use called the Bayer system. And I'll talk about that later on sometime as well, just not today. So just take a minute and try to find Ursa Major and Ursa Minor. They're both in the center of the screen. And again, the way you find Ursa Minor, easiest way, you find Ursa Major first, and you're going to try to find the pointer stars of Ursa Major to find Ursa Minor. So I'm not going to talk about the stars yet of Ursa Major. I'll do that in a minute. I'm just going to talk about the stars of Ursa Minor now. So if you're having trouble finding the constellations, one of the reasons you might be having trouble, obviously, is because you haven't done this before. But there's also a whole lot of stars in this image. You'll notice that the less stars there are, the easier it is to find these constellations. And so this is what you'd see. This is the type of image you'd see of the night sky if you went up to North Georgia or down in South Georgia. If you weren't around anything, you're just out in the middle of nowhere, you're not going to have very much light pollution, and you're going to see the stars really, really well. In a few minutes, I'll show you what the stars would look like where we live around Marietta, Roswell area. But hopefully you found them by now. And so let's just start. This is going to be Ursa Major over here. So this is Ursa Major. That's the tail of the Big Dipper, the Big Bear. And we just come like this. And then that. So this is Ursa Major right there. And so the pointer stars are these two. And I'll go over these names in a few minutes, not yet. We use these pointer stars of Ursa Major, the Big Dipper, and they point to Polaris. So see if you can start here and follow the stars over and make a straight line like this. And the next star you come over to will be the North Star. So see if you can do that. Start there, just go in a straight line until you hit the next star over. So start there, go across, straight line, and then you hit the North Star here. So this is one of the stars you need to know. This is called Polaris. That's the North Star. We talked about that in our last lesson. We know the North Star is above the Earth's axis of rotation. It's above the North Pole, so it doesn't really move in the sky. It's fixed. And so we start there, and that's the tail of the little bear. And then we come like this, connect the dots. There's 1, 2. These dots are stars, of course. So start there, next star over, keep going, right here, right here, right here, and right here. So these are the stars that make up the Little Dipper. So the brightest star in the Little Dipper is Polaris. So Polaris is the North Star. That's the alpha star. You need to know that Polaris is, oops, we can go ahead and keep it there. That's fine. So this is Polaris. And then the second brightest star is called the Beta star. So we come over here. That's this star here. This is Kochab. And then the third brightest is this one. This one is called Firkat. So you have Polaris, Kochab, and Firkad. Those are the three named stars that are in the Little Dipper. Out of those three, the only one I really care about for you knowing is Polaris. You need to know the name of Polaris. If you want to know the name of Kochab, Kochab and Firkad, you can. That's Kochab, that's Firkad. But the only one I care about is Polaris. That's for Ursa Minor. So take a look there. So here's Ursa Major. We'll talk about these in a minute. Ursa Minor. And then over here you have Cepheus, and then there's Cassiopeia. These are the other two circumpolar constellations. I'll talk more about them later on, either this week or beginning of next week. Now take a look here. Is it easier to see Ursa Major and Ursa Minor in this image compared to the first one we saw? So take a look. What's the difference between this and this? Hopefully you can see that Ursa Major and Ursa Minor are a lot easier to see in this image. The reason being there's a lot less stars. So a lot of stars, and then here you have less stars. So the reason you have less stars is because of light pollution. So around where we live, this is the kind of sky that you would see. You would see the sky like this. So the only stars you see over here are the bright stars that are in Ursa Major. So there's the back legs of the bear here. And then here's the bear's butt with the tail. That's Ursa Major. And then follow that over. And you'll notice you can only see the three stars that we just talked about of Ursa Minor. So you have Polaris, Kochab, and Firkad. So those are the three stars you can see. So a little light pollution, if you're new to finding stars and constellations, is actually kind of useful because it makes it a lot easier to see. Over here you got Cepheus. These looks like a house. And then up here you have Cassiopeia. Cassiopeia looks like a W. You can't see it all in this image, but again, we'll talk about that one later on sometime, not today. Okay, so here are the stars again of Polaris, of Ursa Minor, the Little Dipper. So I mentioned these letters here. So this is the Greek alphabet. So that's how you name stars. You name stars by brightness, and that with the system of naming stars by brightness and giving each star a letter. There's a little more to it than this, but it's called the Bayer system. We'll talk about that. Like Polaris in the Bayer system would be called Alpha Ursae Minoris. So Ursae Minoris is the name Ursa Minor in Latin. So the little bear in Latin, that's how you name it. So you say Alpha Ursa Minoris, and I'll talk more about this later on sometime. Now, I know that Polaris is the brightest because of this number right here. So this number tells you the magnitude of the star. Magnitude means the brightness of the star. So you need to know that for your test. You need to know that magnitude means the brightness. The lower the number, the brighter the star. So here we have a magnitude of 1.97. That's for Polaris. Over here you have Kochab, 2.06. And then over here you have Firkad with a magnitude of 3. So alpha star, beta star, gamma star. Alpha Ursa Minoris, beta Ursa Minoris, gamma Ursa Minoris. That's their Bayer system name. The proper name, though, Polaris. That's the only one I want you to know. That's Kochab, and that's Firkad. You can know those if you want, but that's the one I really care about. So Ursa Major. So the way you can tell the difference between Ursa Major and Ursa Minor, Ursa Major, all the stars are big and bright. So here you can see Ursa Major over here. Let's do it right here. And then we'll go over the names of the stars. So over here, we'll start at the tip here. This is called Alkaid. You don't need to know Alkaid. I'm going to go over all the names. The ones that I care about for the Big Dipper, you need to know the binary star system right here, what the binary star system is called, and you have to know the name of the 2 pointer stars. But I'm going to go ahead and give you all of them just so you know. So this is Alkaid. The binary star system here, you have 2 stars, Mizar and Alcor. Here you have Alioth. And then right here when you get to the spoon part of the dipper, right there, that's called Megrez. Here you have Phecta. And then the 2 pointer stars, you need to know these two. This one is called Meroc, and this one is called Duppy or Dubé. You can say it either way. There's about 3 or 4 different pronunciations. But I say Meroc and Duppy. So One more time. Alkaid, Mizar Alcor, Alioth, Migrez, Fecta, Mirak, Dubhi. Out of all those stars, you need to know Mizar Alcor, Mirak, and Dubhi. And these two are the pointer stars, and you can just follow them, and they point straight to Polaris. All right, so let's see if it's easier to see Ursa Major with less stars here. So here you can see this is with a lot of stars, so not very much light pollution. Here there's a few less stars, and then here, yeah, you can definitely see it a lot better right here without with a whole bunch of light pollution. It makes it easier to see. Only the bright stars show up. So you have, again, you have Alkaid, Mizar Alcor, Alioth, it's right here, Migrez, Fecta, and then you have Mirak and Dubhi. So those are the stars of Ursa Major. Those are the Big Dipper. And then there's the bear's back legs, and then his body comes around this way and goes off the screen here. So this is his butt right here, and that's, sorry, this is her butt, and that's her tail. So remember the story. So the big bear is actually Callisto, and the little bear is actually Arcus, her son, and they're going around, circling around the North Star here, trying to run to give each other hugs, and they never can quite make it. So the big bear is running this way, little bear is running this way, and they can never get to each other, ever. That was the story that I told you on Friday of last week. So here are the names of those stars for you. So we said Alkaid, Mizar Alcor, Alioth, Migrez, Fecta, Mirak, and Dubhi. So you can see the numbers represent the brightness or magnitude of the stars. And these are all the other stars that are named in the Big Bear. So here's the head of the bear, here's the front legs, and then there's the back legs. And guys, with that, that's going to be it for a review of Ursa Major, Ursa Minor. And then for the rest of the video, I'm just going to do a little review of what a terrestrial globe is, and then I'm going to show you for the first time what a celestial sphere is. Hey guys, today I want to do a little review with you over what this thing is right here. So we did an activity about 2 weeks ago when we talked about latitude and longitude, and we used an online version of this. So this is called a terrestrial globe. The reason it's called a terrestrial globe is because terrestrial means Earth-like. And so just like you have terrestrial planets, your terrestrial planets are Mercury, Venus, Earth, and Mars. So terrestrial means they're like the Earth, which means it's solid. They're made of rocks and minerals. So this globe here is terrestrial because it's an Earth-like globe. It is a globe of the Earth. And when we were doing that activity, we learned about latitude and longitude. So I just want to show you a couple points here that you're going to need to know for your test. So hopefully you can see that there's these grid lines here. There's grid lines that run like this, going up and down. And then there's also these grid lines that are running across, going left and right. So let's start with these grid lines first. So first thing we have to know is the point on the top of the Earth. Hopefully we know what that's called. So that's the North Pole. So North Pole is up here in the north. That's the North Pole, which means on the very bottom, down here, that would be called the South Pole on the very bottom. So what are the lines called that run from the North Pole all the way down to the South Pole? You'll notice that these lines are running vertically, and they're actually going to increase in number going left and right. So they run vertically, increasing going left or right. Those lines are called longitude. So these are your longitude lines, these lines that run vertically. The other type of line, which are running like this, going across the Earth, they actually increase in number. You see that right there? So they increase or decrease going up or down. These are called latitude lines. The way I remember it, think of the fattest part of the Earth here. So remember that the Earth shape is oblate, which means it's fat in the center. So there's this one line that runs right here, separating the northern hemisphere from the southern hemisphere. That line is called the equator. So the equator would be 0 degrees latitude, 0 degrees latitude. You also have this other line running right here. You can see it's darker than the other lines. this line would be your 0 degrees longitude. So this line is called the prime meridian. This line is called the equator. And we need to know something important about the prime meridian. We need to know that's the 0 degrees longitude. And the reason the prime meridian runs this way is because of this location right here in England. So in England up here, you've got Greenwich, England. That's actually the 0 degree mark for longitude. It runs through Greenwich, England. The reason it runs through Greenwich, England is because that's where the Royal Observatory is, very famous observatory. That's where the system started. So they made that point right there in Greenwich, England, the 0 degree mark for longitude. So longitude lines run north and south, increase going east or west. Remember, there's 360 degrees and around the Earth, and there's two hemispheres. So you have an eastern part and a western part, which means there's 180 degrees on one side, 180 degrees on the other, for a total of 360 degrees. So longitude cannot be any higher than 180 degrees. Latitude, on the other hand, if we start here with 0 degrees, the equator separating the northern hemisphere from the southern hemisphere, you go from 0 degrees all the way to the tippy top. So that would make a right angle. It's a right angle. So that means it can go all the way up to 90 degrees. Once you go past 90, you're on your way back down towards the equator. So you can see the right angle right here, there, and up. That's a right angle. 90 degrees is what a right angle makes. So the highest you can go for latitude is 90 degrees. After that, you start going back down. So you have 90 degrees north or 90 degrees south. Now, that's for the terrestrial globe here. Next thing I want to show you, so that's for finding latitude and longitudes on the Earth. The next thing I'm going to show you is a celestial sphere. So before I show you the celestial sphere, let me just talk about this for a minute as well. So you can see here, if we look here, this is the 0 degrees north, 0 degrees south line. That's the equator. And then here we can see that each line we go up, it's actually 15 degrees for each line. 15, 30, 45, 60, 75, and then 90 is all the way up top. It doesn't necessarily have to be 15 degrees for each line. It really depends on the globe. Sometimes it could be 10 degrees. It just depends on what kind of globe you're looking at. But the way you figure it out, well, you know from the equator to the North Pole is 90 degrees. So you just got to figure out how many lines it takes to go 90 degrees. So for instance, if it takes 9 lines to go from the equator all the way up to 90, you know 90 divided by 9 would be 10 degrees. That means that each line would be worth 10 degrees. But in this situation, each line is 15 degrees because it actually tells me. And then on the equator itself, you can see these measurements saying, this one says 45 degrees west, 30 degrees west, and then we go 15 degrees west to 0 degrees west, and then there's 0 degrees east. So this tells you your longitude, and we can see that each one of the longitude lines is also 15 degrees. So latitude, longitude is measured in degrees, and latitude, longitude shows you the fixed coordinates of places on the Earth. Remember that where we live, right here in Georgia, in Atlanta, Georgia, right up there. That's where we are. You can see we are, that says, sorry, 30 degrees north there. We're above the 30 degrees north line. So there we are right up there. So we are there between 30 degrees and 45 degrees. So hopefully you can figure out our latitude, longitude there. And then you can see we are between 75 and 90 degrees. So we're right around 84 degrees west. And then right up there. So you can figure that out. Okay, so that's a terrestrial globe. North Pole, South Pole, equator, and then the prime meridian runs through Greenwich, England, right there. So we got to know that. So that's the terrestrial globe. So now compare that to this. So this is called a celestial sphere. So you can see the difference. Celestial sphere, terrestrial globe. So terrestrial globe is just the Earth itself, a globe like the Earth. Now if you look at the celestial sphere, you'll see that there's this big plastic, and you can hopefully see these grid lines. There are grid lines on it, just like there were grid lines on the Earth here. And then if you look in the very center of the celestial sphere, you should see that there is an Earth there. So you can see the Earth in the center. So in the celestial sphere, the Earth is the center, And then all the stars in the sky, except for our sun, this yellow circle right here that represents the sun, are fixed on this grid. And so since these stars are fixed on this grid, what we can figure out by looking at the grid lines is we can figure out the right ascension and declination. So if you remember, latitude, longitude was the global coordinate system for finding things on the Earth. Right ascension, declination is the global coordinate system for finding things on the celestial sphere. So we're going to talk a lot more about the celestial sphere coming up. I'm just kind of giving you an introduction into what the celestial sphere is today. So you can see on the Earth, there is that pole that runs from the North Pole up into the sky. That's actually called the celestial North Pole. And then down below, you can see that there's that pole running from the South Pole down to the sky. That's called the South Celestial Pole. And then, hopefully you can see this line right here where my finger is. This is the line that separates the northern celestial hemisphere from the southern celestial hemisphere. This is called the celestial equator. Right here, that's the celestial equator, separating the two hemispheres. Now, on the Earth, we have the prime meridian. In the celestial sky, celestial sphere here, you don't have a prime meridian. Each one of these lines is called a celestial meridian. So you have these celestial meridians, which run like this, and then you have these lines here. We'll talk about those in a minute. So with these lines, we can figure out what our right ascension and declination are. So the lines that are running like this, so you'll notice they increase going north or south. These are called declination lines. And then the lines that are running like this, these meridians, these lines are called your right ascension lines. Declination is measured in degrees. Right ascension, the lines that are running like this, are measured in hours and minutes. And I don't expect that to make sense to you yet. We're going to do a lot more of this coming up in the next 2 weeks. But this is just, I'm just showing you right now what the celestial sphere is. So this is a celestial sphere. The Earth is in the center, and all stars, except for the sun, that yellow thing right there is the sun, all the stars in the sky are fixed on this grid, where these lines represent declination lines. These lines running down like this represent right ascension lines. Declination is measured in degrees. Right ascension is measured in hours and minutes. Okay, so terrestrial globe, latitude, longitude, both measured in degrees. These are called longitude lines. These are called latitude lines, both measured in degrees. Declination is measured in degrees. Right ascension is measured in hours and minutes. So one more thing for review for what we've been talking about. We've also talked about the local coordinate system for finding objects in the sky. So this is the global coordinate system. The local coordinate system, from your readings that you've done, we learned about how you can use your hands to find measurements of objects in the sky. So we need to know what this means. So for instance, here's one finger. So one finger can mean this. You could use this to measure your altitude of something in the sky, or the azimuth of something. Altitude and azimuth are both measured in degrees, and a finger, one digit, would be 1 degree. It can vary between 1 to 2 degrees, but for, say, our quiz that we have coming up, we would say that this would be 1 degree. Now your fist could be different sizes depending on the size of your fist, and we're actually going to do an activity later on this week where you're going to figure out your hand positions. You know, how much is your finger, your fist, your outstretched hand, you know, what is this? So we're going to, you got to figure out the size of your big hand and little hand. We're going to do an activity with that. But on average, this is 10 degrees. So this is 1 degree, this is 10 degrees. And then the outstretched hand, this is on average, it's 18 degrees. Some people it might be 20 degrees, but on average this is 18. And then usually this right here, this is 15 degrees. So that's about 1, 10, 15, 18 on average. So with this, we're going to figure out how to use our hands as measurement tools for figuring out altitude and azimuth, and we'll do an activity with this later on this week. This stuff that I'm reviewing with you today, this is what's going to be on our quiz. Our quiz will be on Thursday of this week. So just want to do that with you, and I'll talk to you later, guys. Bye.